All right, we're going to talk about the interface data type. Now, we've created three different types here. We've created a rectangle, we've created a circle, and we've created our equilateral triangle as well. Now, let's say if we want to create a function that could take any one of these three, well, we still have to tell the compiler what type it should expect. Remember that Go is statically typed. If we don't put a type here, it's going to have a compile error, or if we try and pass in a type that doesn't match the type it's expecting, it's going to be a compile error. We run into a little bit of a problem. So we have three different types here that, from the compiler's perspective, are not related. And what we want to do is tell the compiler, like, hey, all three of these are related, they have similar behavior, and we want to be able to just pass in any one of those three. And that's where we're going to go ahead and make our interface. So our interface, which we're going to call shape, it's created just like any other type we create. We use the type keyword, we give it a name, and this one is of type interface. Now, an interface is just a list of methods, and you could think of methods as the behaviors of those particular things. So we only have one method in our list right now, and that's perimeter. So all three of these have a method that's called perimeter. As you can see, we have one for rectangle, and it returns the perimeter, and we have one for circle. It also returns a perimeter, and of course, our triangle returns a perimeter as well. So basically how an interface works is anything that implements the methods on this list is of that type. So all three of those, since the rectangle, the circle, and the triangle all implement this method, they all have, basically we're saying it has this behavior, it is of type shape. So that's why we're going to be able to pass in any one of these three into this find perimeter function. Let's go down to our code and let's go ahead and run this. Now this first part's just going to show, it's just going to print off what the methods are returning. So, A, which is our rectangle, it returns a perimeter of 30. B, which is a type circle, returns 22 something, and then C, which is our triangle, returns 9. Now let's go ahead and run our find perim function. And the magic here you'll see is that we are passing in obviously three different types, but they're all of the same type shape because they all implement the same behavior, the same methods. There we go. So we went ahead and took these three unrelated types and we showed the compiler, like, hey, these are related. They're all of the same interface. They all implement the same methods. Now, I went ahead and created another method here, area, for rectangle. Now, I purposely didn't make one for circle or for our triangle. So let's just run that real quick. And it returns our area. Now, like I said, this interface is a list of methods. For something to be of type shape or of this interface, it has to implement all of these methods. Now, as you probably already imagined, being that only one of these three shapes implements an area method, well, that's going to make these other two no longer be of this type of interface. It's no longer a shape. So circle doesn't have an area method, and our triangle doesn't have an area method. So they're no longer that type. They're no longer a shape. So let's go ahead and run this. As you can see, the compiler already sees this as an error. Yep, there we go. cannot use B, type circle as type shape in argument find param. So I cannot pass in B, it is not a shape. So just like we said, and circle does not implement shape, it's missing a method. Since we, in our method list here, being it doesn't have this method, it is no longer a shape. Now I could create another method, area for, for a circle and for our triangle, and that would fix this issue. Or I could just simply just take this off of our list. All right, so hopefully that helps you out. You can see that we can take these different types that are unrelated from the compiler's perspective, and we can explain like, hey, these are related, these have the same behaviors, and you can treat them as the same type or interface. So, well, I hope that was helpful, and I'll see you in the next one.